Here is a AP Chemistry energy problem from 2006, letter B. I'll read through the entire problem, solving on the fly as we can, then we'll compare it to the calculated answers. I see that carbon monoxide can be burned. You can combine a little more oxygen to it and turn it into carbon dioxide. And we have some data here. Standard enthalpy of formation. Here we've got carbon plus oxygen turning carbon monoxide. We've also got carbon plus oxygen turning into carbon dioxide. And they'd like to find the value of this reaction, the enthalpy for this reaction here. I think this is a Hess's law problem. I think that since this is a reactant, if I flip this over and leave this one as is and then combine them, I'll get the energy for the combined reactions. I know that carbon will cancel, half an oxygen will cancel, and it'll work out fine. That means I'm flipping this value, so it's plus 10 combined with the minus 393. I think it's going to be about minus 283. Letter B. That is kilojoules per mole. Letter B, determine the value of the standard entropy change. Here we have some standard entropies for products and reactants. So let's do products minus reactants. Everything's a gas here, so we've got 198, call it, minus 213. That's a little negative. Minus another 102, since it's only about half of that. And so I think we'll be negative overall. Fine, products minus reactants. Let's get the standard energy and free energy change. So many years they do this problem. It's delta G equals delta H minus T delta S, and you've calculated delta H, you've calculated delta S, you know your T, so plug in, you'll get your delta G. And is it spontaneous? Well, if it's negative, and I think it is, it's burning. If it's negative, it will be spontaneous. And then they also want the equilibrium constant, and that is KEQ equals e to the minus delta G over RT. You'd have to plug in all those numbers. R is 8.314 joules per Kelvin mole, so make sure you're using joules, not kilojoules, and you'll get your answer for that too. How'd we do? Let's see. Sum of products minus reactants for A is minus 283. Yep, looks good. B, we have products minus reactants here. You know, they did products minus reactants, but me, it's like combine them and flip one of them. Now, you could do it that way if you want. You get the same answer. I always flip them and combine them using a line there. I never do them this way. But for this one, I do. Products minus reactants, and it is negative. Minus 87 about joules per Kelvin. Now we got both of them. We plug into this, and we get a big, healthy kilojoules number. That means it's spontaneous, fine. And finally, we have to calculate K. Watch out because we need joules here. So look at the size of that value when we have joules, because that's 8.31 joules per Kelvin mole, and there's your Kelvin there, and you get an insanely close to infinity type of equilibrium constant. Okay, that's AP Chemistry 2006B, the free response question.